My name is Srinivas. I'm working as an assistant professor in IARE College. Today we'll discuss the routines available in SQL Server. We have three types of routines in SQL Server. Okay, what are routines? Routines are programmable objects that encapsulate code to calculate a result or to execute activity. Okay, it is like a piece of SQL code encapsulated into an object to calculate the result and to execute the activity. So we have three types of routines here: user-defined functions, store procedures, triggers. Okay, UDF also user-defined functions. Rest, store procedures, triggers. The SQL Server allows you to choose whether to develop a routine with T-SQL or with Microsoft .NET code based upon the CLR integration in the product. SQL Server allows you to choose to write a routine with T-SQL or Microsoft .NET based CLR code. Okay. Generally speaking, when the task at hand mainly involves data manipulation, T-SQL is usually a better choice. When the task is more about creative logic, string manipulations, or computational intensive operations, the .NET code is usually a better choice. Okay, now let us start with user-defined functions, right? Okay, user-defined functions. The purpose of a user-defined function, also known as UDF, is to encapsulate logic that calculates something, possibly based upon the input parameters and returns a result. Okay, it is a piece of code which is encapsulated to calculate something based upon input parameter. For example, you want to add two some numbers. So what do you have to give two parameters? A and B. A is the first parameter, B is the second parameter, and we want to calculate the sum. That sum logic will write in the function or procedure. That logic is encapsulated into an object. The object can be a SQL store procedure or an UDF. Okay. SQL Server supports scalar and table valued UDFs. One is scalar and table valued UDFs. SQL Server supports two type of functions. One is the scalar and the table valued. Okay. What is a scalar variable? Scalar user-defined function. This scalar UDF function will return you a single value. Suppose you want to add two numbers a comma b. So the output would be c is equal to a plus b. That is, the scalar will return a single value, whereas the tabled valued UDF returns a table. The table valued UDF returns a table. On benefit of using UDF is that you can incorporate them in the queries directly. When the is you can directly call these functions in your select queries. Okay, scalar UDFs can appear anywhere in the query, where an expression that returns a single value can appear in the select list only. Scalar UDFs can appear anywhere in the query, where an expression that returns a single value can appear. For example, select get date. Select get date is a function. You can directly call that select in the select statement. Okay. Table UDFs can appear in the from clause of a query, whereas scalar UDFs can appear only in the select statement, the select list, and the table UDFs can appear in the from clause of the query. Right. Now we'll see an example of a scalar UDF. Okay. For example, the following code creates an user-defined function called DBO is the schema dot get age is my UDF name. My scalar UDF name is get age, which that returns the age of a person, the specified birth date. So you pass the birth date as an input parameter. Okay, then we can calculate the age. That logic is written in the function called get age. So the get age that returns the age of the person with the specified birth date at a specified event date. that event date argument. For example, create function. The syntax would be create function, function name, then the input parameter if any. So here I am passing the birth date, and event date. Event date is the current date. Maybe for example, I'm taking this current date. Okay. Now it will get now the logic is it function always returns an output. Function always returns a value, that is return hint. Returns is the keyword, and integer is I'm expecting the date of birth to return the value of in the form of int as begin. Again return dative. I'm using dative function to calculate the year, the number of years between two dates. The first date is the birth date which of the student, and the event date is the current date. Okay. So I say select. I can as you know that the scalar UDF can be directly be used in the select statement. Okay. So select name comma date of birth comma DBO is the schema name. The function name is get age. It takes two parameters. One is the date of birth followed by the current date. I want to calculate against today, right? So as age, where student is equal to 1, I'm trying to fetch the number of the get age of a student of whose roll number is 1. So I say select name comma date of birth comma the function name is this get age, takes two arguments. One is the date of birth and the current date. So the difference of these two dates let me the get age. This is how you call that get age in a scalar user defined function. Okay, this we can directly call in the select statement, whereas the table variable can be included in the from clause. We'll see that in the next example. Now here I am creating a table UDF example. Okay, create function name is get table data, which now as I said, function always returns something, a value. So returns table. I'm returning a table data into a table format as written select star from students. Okay. Now as we know that the table UDF table UDF can be called from clause. So select star from the function name is get table data where student is equal to 1. By this we can call the table UDF, right? So my output would be student. Because I'm asking only for student 1 data, so it will be student 1 name of the student, branch ID, and the date of birth. Okay. Earlier in the scalar UDF, you wanted the age of the student by passing his date of birth, and you want the difference between the current date. Here I am returning the table data itself for the student called 1. So I'll get all the details of the student 1 when I use a table UDF. Okay. Now let us see the next store procedure. We have seen the user defined functions. Now let us concentrate on the store procedures. The stored procedures are server-side routines that encapsulate T-SQL code. Stored procedures can have input and output parameters. They can return result sets of queries, and they are allowed to invoke code that has side effects. See, like function, these also stored procedures are server-side routines that encapsulate SQL code, and they can have an input and output parameters. They can return the result sets of queries, and they're allowed to invoke code that has side effects. Not only you can modify data through stored procedures, you can also apply schema changes through them. Apart from making changes to the data using stored procedures, you can also apply the schema changes to them. Okay. Now compared to an ad hoc code is nothing but you're writing the select statement on a query analyzer. Select star from EMP, select star from a table name. Now we'll see what is the comparison between that two stored procedures. The user stored procedures gives you many benefits. Stored procedures encapsulate logic. If you need to change the implementation of a stored procedure, you can apply the change in one place. in the database, and the procedure will be altered for all users of the procedure. Suppose you wanted to write in the store procedure, select star from EMP, but you have changed the name of the table to select star from employee. So you have to change the store procedure at one place only. Select star from employee from EMP. If you make this change, the end users who all are using the EMP table, they need not make changes to that employee. They can directly use this source procedure. So by this, if you make change at one place, the changes will be affected for all the users of the procedure. The store procedures gives you better control of security. Store procedures gives you better control of security. You can grant user permissions to execute the procedure without granting the user direct permissions to perform the underlying activities. This store procedure gives you a better control of security. Suppose you don't know. Suppose you want only few persons to execute to see the data. So granting the permission to the particular store procedure to particular users, only they will be able to use the store procedure the data. But those who don't have access cannot view the data. For example, suppose you want to allow certain users to delete a customer from the database. Okay, you want to allow certain users to delete a customer from the database, but you don't want to grant them direct permission to delete the rows from customer table. See, customer table is master table, and you want some users to delete a customer from a database. But you can include that logic in a stored procedure so that they will not have access to directly the customer table. Now, let us give an example. You want to ensure that the request to delete a customer are validated. Like you can't directly delete a customer who is having open orders or open dates. So that logic, what you want to have is written everything in the store procedures. You want to ensure that the request to delete a customer are validated. For example, by checking whether the customer has open orders or open debts, and you may also want to audit the request. By not granting the direct permission to delete the rows from the customer table, but instead granting permission to execute the source procedure that handles the task, and you ensure that all the required validation auditing also takes place. So instead of directly giving access to customer table, you write the logic in the store procedure. The logic could be that the customers will not have any open orders or open debts and etc. Only if that logic is satisfied, then the customer would be deleted from the database. So by giving this the store procedure to your end users to users, they can safely use this because the logic is written is the logic to delete a customer is written based upon few validations. The validations are all taken place in the store procedures. In addition, the store procedures can help prevent SQL injection, especially when they replace an ad hoc SQL from the client with the parameters. You're right. The SQL injection is nothing but in the ad hoc queries based on parameters, you can modify the thing. So yeah, the store procedures logic is not seen outside. So instead of the ad hoc, the store procedures have much more security. You can incorporate all error handling code within a procedure, silently taking corrective actions wherever relevant. When you have written a store procedure, the logic is written in the store procedures. You can also do error handling. Suppose you are dividing by 0, then you get error. That error is not directly thrown to the user, but we can also use a try and catch block to catch the exception and present the user in a more meaningful way. Stored procedures gives you performance benefits. Stored procedures reuse execution plans by default, whereas SQL Server is more conservative with the use of ad hoc plans. This once the stored procedure is compiled, next time when we execute, it uses the execution plan by default, so that your query processing will be very faster. Another performance benefit of using stored procedure is reduction of network traffic, because you only will see you will see that why it is only one hit and you get the data. Instead of writing multiple queries and going to server, coming back for the result, but the store procedure will reduce the network traffic. The client application needs to submit only the procedure name and the argument to SQL server. The server processes all of the procedure code and returns the only output back to the caller. No back and forth traffic is associated with the intermediate steps of the procedure. It means you have a procedure that have a few SQL queries written inside. Once you call the procedure, the entire request is sent to the server. There in the server, the processing is done, and at a time the entire result set is given back to the user. Instead of going for one query, go hit the server, get the data, second query, third query. Instead of going multiple times, your data is only sent once to the server, and from the request sent to the server, and in return you get the data at one go. Right now, we'll see an example like how to create a procedure. Here the syntax would be create procedure name, get the student details. As here I am not passing any parameter. Procedure can have parameter, input or output parameter, but here I am not passing any parameter. I am saying create procedure name as you write your what you want to get from the database. So I wanted the select star from students. Select star from students will give you the entire student list from the store procedure from the database. Now, how do you execute the procedure? By the command to execute the store procedure would be exec student the procedure name. Exec is the way how we can call the store procedure. The procedure name is get student details. Okay, let us see once again. The syntax to create procedure is create procedure name as begin and end. Okay, here the logic what you want to must be enclosed between the begin and end. Here I don't have begin and end. Say select star from a student. This is my logic to which I want to retrieve from the database. So by using exec get student details, I'm getting the data in the format of this one. My data from the student table is written. If I directly give this get student details to all end users, they are least bothered from where I'm getting this data. They cannot directly access this data. Select star from student because this is a master table. They might corrupt the data. They might update, delete the data. Instead of this, I directly give the permissions on this object called get student details procedure to the end users. Suppose the counselor wants the details of all students. Instead of granting access to select star from students, I'll just say execute get student details. I'll give to the counselor. Counselor will not know what is the underlying table. He'll just see this data. With this data, he cannot modify or update anything. Right? This is the way of creating a store procedure without any parameters. There is one more example how to create a store procedure by passing a parameter. See, the syntax would be create procedure name. In the brackets, you have to pass the variable and it is data type. Here I am passing a variable called as @student ID. Means in variable. The variable name is student ID. Okay, and the data type of this is integer. So when I pass here the logic I'm putting is select star from student where student ID is equal to the given input parameter is @student ID. I'm passing this to the store procedure. Now, how do we call the store procedure? By exec. Exec get single student details. Here in the first example, we are getting the entire data as we are not passed any parameter. But in this case, I am passing a parameter for one student. I want to get the student details. So I am passing the student ID as the variable, which is the integer type. So get single student details, passing one as the integer input parameter, and exec is how we call the store procedure. How do you call a store procedure? So exec get single student details. This will give me the data of only one student instead of all the student data. If I want to the end users to see a particular student record, by this logic I can get the data of single students. This, thank you. This completes the routines in SQL Server.
Like, share and subscribe. Hit the bell icon for more updates.